Okay, I think this is going to work, so hopefully. I don't have much time, so I'm going to go through this rather swiftly. This is what we're working on, we're working on residual plots, the investigation, okay? You should have this paper. If you don't have this paper, that's all right. Ask me and I'll give you. All right, so this is kind of what I did before, so I'm going to try to walk you through what's going on right here. What I did is I took the time it takes to take a test and the score you get on a test. And in green, you can see I plotted the actual data, okay? So I've gone through and I actually made a chart and I've actually plotted what I've actually done. So it took 10 minutes, you got to score about 20. You took 20 minutes, some people got to score 30. Some people for 20 minutes also got to score about 60. So this shows me what actually happened. Alright, so my green dots, which has actually happened. In red, what you'll see, I created from this data a best fit line. Now you can do all this by a calculator, that's fine. I did it by hand. But you're going to have a table, you'll plug in your calculator, like we did with linear regression. You're going to create a best fit line, and from that best fit line, you're going to see what the predicted would have been. So here's my best fit line, and I've put some dots in red so you can see what the predicted values would have been. So 10 minutes, you should have made around 12, 20 minutes on the test, around 28, 30 minutes on the test, around 45, and I put those values here in red, okay? Now, a residual, what we want to do with the residual plot is find out, is the best fit line really the best model? Is this the best way to understand what's happening with this data? So, what we're going to do is we're going to take the actual data and the predicted data and we subtract them, okay? And when you do that, we get these numbers here, we call them residuals. And we're going to plot them. Now, when you plot them, it's a different type of graph than this. We're going to have, your standard x-axis, which is still time, okay, so 10 minutes, 20 minutes, 30 minutes, so forth. But the residual side, this is your y-axis. It tells, depending on how varied your numbers are, it's going to vary. So like here, this goes up to 8. So for 10 minutes, the difference between the predicted and the actual is about 8. Here, for 20 minutes, the difference is about 2. But for 30 minutes, the difference was about 35. Okay, so that's why this point's way down here. And as I kept going, the points seemed kind of random, which is good. When the points seem random for the residual plot, that means the line is the best model for this data set. Okay? If the points did not seem random at all, but seemed to be presented in somewhat of a pattern, that means a line is not the best model for this data. It could have been we needed a curve, a quadratic curve or an exponential curve, in which case we would have to have a more complicated formula to represent that data. Alright, so that's kind of where we're at with residual. What you're going to do is you are going to use this data, create a best fit line. I want you to also calculate the correlation component, which it should do automatically if you set your calculator right, like I showed you in the last video. And then what you're going to do is you're going to write what the predicted values would be, and then what the residual values would be, and you're going to plot it. And so this is all practice, okay? So good luck. If you have any questions, let me know. I'd be happy to help you.